Hello, welcome to this course on modeling, analysis and estimation of three-phase unbalanced power network. In the last lecture, we have talked about the transposition of transmission line. Today, we will look into the calculation of sequence impedances of a transmission network or rather sequence impedances of a transmission line. So, we know that in general the Z ABC matrix of any ABC domain is given by ZAA, ZAB, ZAC, ZBA, ZBB, ZBC and ZCA, ZCB, ZCC, that we already know. Also, because this matrix is symmetrical, so then therefore ZAB is equal to ZBA, ZAC is equal to ZCA and ZBC is equal to ZCB. Now, the relation between voltage and current of this transmission line would be essentially VABC is equal to ZABC into IABC. Of course, we know that VABC is basically a vector, it is VA, VB, VC transpose and IABC is actually IA, IB, IC transpose. Now, we know that from the ABC domain I can transfer to the sequence domain by this matrix. This is VA0, VA1, VA2. So, this matrix is known as in general it is known as the A matrix, and where of course we know that A is 1 angle 20 degree, and this relation can be written as essentially written as VABC is equal to A V012, where V012 is another vector given by VA0, VA1, VA2 transpose. Now, if I use this relation here, and then of course in the same token I can write down that ABC is equal to A into I012, where I012 is again a column vector of the zero sequence current, positive sequence current as well as the negative sequence current. Now, with this relation, if I now start with this relation that VABC is equal to ZABC into IABC, then what I can do is that I can write down this equation AV012 is equal to ZABC into AI012, or in other words I can write down that V012 is equal to A inverse ZABC into A into I012. Now this quantity, now because this is also in zero sequence, positive sequence and negative sequence domain, so we call this is basically the sequence voltages. This is also nothing but the sequence current. So then therefore this relation relates the sequence voltages with that of the sequence current. So then therefore this expression is known as sequence impedance. So sequence impedance is given by A inverse Z ABC into A. So this is the sequence impedance. So this is the sequence impedance matrix. So this is sequence impedance matrix. Also we know this following relation, that the inverse of this matrix A is given by 1 by 3 into 1 1 1 then 1 A square then 1 square A. This is also known to us. So now, sorry, this is A inverse. So then therefore we will now use this expression of A inverse ZABC and A to calculate the matrix Z012. So then therefore Z012 is equal to 1 by 3 1 1 1 1 A square 1 square A then ZA ZAB So then therefore so this would be ZAA plus ZAB plus ZAC, then this is ZAA plus A square ZAB plus A ZAC and ZAA plus A ZAB plus A square ZAC then ZBA plus ZBB plus ZBC then ZBA A square ZBB plus AZBC ZBA ZBB plus A square ZBC, then ZCA plus Z. Now, if I say that this, now these would be basically given as Z00, Z01, Z02, Z10, Z11, Z12, Z20, Z21, Z22. Suppose I say that these are the things. Now what is Z00? Z00 is of course 1 by 3 into ZA plus ZAB plus ZAC plus ZBA plus ZBB plus ZBC plus ZCA plus ZCB ZCB plus ZCC. So this I can write down as 1 by 3 into ZA plus ZBB plus ZCC plus 2 by 3 plus 1 by 3 plus 2 by 3 ZAB plus ZBC plus ZCA. Alright. So we call it as ZSO plus 2ZMO, right, where ZSO is 1 by 3 into ZA plus ZBB plus ZCC, and ZMO is 1 by 3 to ZAB plus ZBC plus ZCA. So this is the first relation. So then therefore, well, let me that ZOO is equal to so this is the first relation. Okay. Now, what is Z01? Z01 of course would be 1 by 3 ZA plus ZAA plus A square ZAB plus AZAC plus ZBA plus A square ZBB plus AZBC plus ZCA plus A square ZCB plus AZCC. So this I can write down as ZS2 this I can write down as 1 by 3, it will be 1 by 3 into ZAA plus A square ZBB plus AZCC. Then now let us look at now ZAB is equal to ZBA. So then therefore these two combine is 1 plus A square into ZAB, this plus this. Okay, now let us just do one thing, one rough calculation. If I combine A square ZAB plus ZBA, that is equal to A square ZAB plus ZAB, because we have already, because this matrix is basically symmetrical, because this impedance matrix is symmetrical. So that means it is 1 plus A square into ZAB, that is equal to minus AZAB, as we know that 1 plus A square is equal to 0. So for all these terms we will use this relations, or rather use this kind of relation. So then therefore if I do combine A square ZAB and ZBA, this comes out to be minus 1 by 3 into AZAB. Then if I basically combine AZAC and ZCA, so then therefore following this AZAC and ZCA would be minus of A square ZCA, and then if I combine AZBC and A square ZCB, this will be minus ZBC, right. So basically that will happen. So then therefore we write it as that Z01 is equal to ZS2 minus ZM2, where ZS2 is this much, where ZS2 is this and ZM2 is this. So this is ZM2, this is ZM2, and this quantity is ZS2, right. And then So this is Z01. So let us now look at Z02. So Z02 would be 1 by 3, Z02 would be 1 by 3 ZA plus AZAB plus A square ZAC, ZAA plus AZAB plus A square ZAC, then ZBA plus AZBB plus A square ZBC, sorry, ZBA plus AZBB plus A square ZBC plus ZCA plus AZCB, ZCA plus AZCB, ZCA plus AZCB plus A square ZCC. So this I can write down as 1 by 3 ZAA plus AZBB plus AZCC, A square ZCC, and then again AZAB plus AZAB plus ZBA. So it is also ZAB. A plus 1 is minus A square. So minus 1 by 3 A square ZAB. Then it would be plus A square ZAC, and ZCA means ZAC. A square plus 1 is minus A. So min AZCA, and then A square ZBC plus AZBC, or rather AZCB means AZBC. So A square plus A is minus 1. So plus ZBC. Right. So we write it as Z02 is equal to ZS1 minus ZN1. Where this is ZS1 and this is Zn1, right. So we have got the first row. Now let us look at the second row. So second row is, so Z10 would be Z10 1 by 3 into ZA plus ZAB plus ZAC, ZA plus AZBA plus AZBB plus AZBC, AZBA AZBC plus A square ZCA CBCC. Right. So then therefore what I will get here? So I get here 1 by 3 . ZAA, then I get AZBB, then I get A square ZCC. So, this is nothing but ZS1, and then what I get? I get ZAB and AZAB. So, minus A square ZAB. So, it is minus 1 by 3 A square ZAB. Then ZAC, 1 ZAC and A square ZCA. So, 1 plus A square is minus AZCA. So, this is plus AZCA, and then I get AZBC and A square ZBC. So, plus ZBC. So, this is also, so I can say that Z10 is also ZS1 minus Z. Right. Then the next one is Z11. So, Z11 would be Z11 would be ZAA plus the square ZAB plus AZAC, ZAA plus A square ZAB plus AZAC, right. Then AZBA, AZBA plus we have A cube ZBB means ZBB plus A square ZBC. Please note here we are also using the fact that A cube is equal to 1. We are also using this fact that A cube is equal to 1, right. So, that also we are using, and then A square ZCA, sorry, plus A square ZCA plus A square A to the power 4 means A. So, AZCB plus A square into A is A cube, sorry, A square into A is A cube, so ZCC, right. So, what I got? I got 1 by 3 to ZAA plus ZBB plus ZCC, and then what I get? I get ZAB. Let us look at ZAB, A square ZAB and AZAB, A square plus A is minus 1. So, minus 1 by 3 ZAB, and then we have AZAC and A square ZCA means A square ZAC, A plus A square is minus 1. So, plus ZCA, and then A square ZBC and AZBC, this is also ZBC. So, we have already seen that this is nothing but ZSA. So, this is nothing but ZSO and this is nothing but ZAO. MO. So then therefore I can write down that Z11 is equal to Z SO minus Z MO. Right, because this quantity is ZSO and this quantity is ZMO, that we have already defined. So now what is Z12? Z12, 1 by 3 is common, ZA plus AZAB plus A square ZAC, ZA plus A square ZAC plus, then AZBA plus A square ZBB, AZBA plus A square ZBB plus A cube ZBC, A cube means 1, so plus ZBC, and then plus multiplied A square ZCA plus ZCB, A square ZCA plus ZCB plus A square A to the power 4 ZCC means AZCC. So it would be 1 by 3 ZA plus A square ZBB plus AZCC. So ZA plus A square, and then what we get plus, so it is 2 by 3 AZAB plus AZBB plus A square ZCA plus ZBC. Right, now we have seen that AZAB plus A square ZCA plus ZBC is ZM2, and ZAA plus A square ZBB plus AZCC is ZS2. So then therefore I can write down that Z12 is equal to ZS2 plus twice ZM2. Okay. So this is Z12. So now let us look at Z20. So Z20 would be 1 by 3 ZA plus ZAB plus ZBC, ZA plus ZAB plus ZBC plus A square ZBA BBBC plus AZCA CBCC. So I can write it down as ZA plus A square ZBB, A square ZBB plus AZCC. So, this quantity is ZS2, ZS2, and then ZAB, then ZAB plus A square ZAB minus AZAB. 1 plus A square is AZAB, then plus ZBC, this is A. 1 plus AZBC means A square ZBC, and then A square ZAB plus ZBC, ZA plus ZAB plus ZAC, ZAB plus ZAC, ZAB plus ZAC. So, 1 plus A square is ZAB, AZAB, and then ZAC, and then A square ZAC, ZAC and AZAC means A square ZAC, square ZAC, and then A square Z, okay, ZAC and 1 plus A is A square, and then ZBC, A square ZBC, A square ZBC plus AZBC means plus ZBC, right. So, AZAB plus A square ZCA and ZBC. So, I can also write it down as CA. So, this also I can write it down CA. So, then therefore, this quantity is ZM2. So, then therefore, I can write down the Z20 is essentially ZS2 minus ZM2. So, this is the relation. Okay, so we will continue and we will complete the remaining derivations in the next lecture.